Hello.
Okay, good. All right. So, picking up from where we left off last class, today the topic is about, so there's a few slides on the history of Linux to sort of set the context of the course. And then we're going to talk about the file system, which is just a few pages in the course notes. I think it's like 2 or 3 pages. But I'm going to spend like a whole lecture expanding on it. So to start, we've got more stupid Linux fun. You can play PacMan in your console if you want. There you go. So you're the little C moving around, and the ghosts are the ampersands, and so on and so on and so on. Now the cool thing about this is that the source code for this is on GitHub. So you can actually go in and see how people are doing this sort of thing, if you want. All right, slide. Okay, here we go. So Linux is, when people say Linux, usually they mean the operating system. Right? So usually they mean the GNU Linux OS. But the Linux is actually what's called the kernel of the OS. Right? So the kernel is the central part of the OS that provides an interface for other programs to access the hardware of the underlying computer. Right? So the kernel sits between the hardware and all the other applications that need to use the hardware. Right? Hardware can mean anything. Right? It can mean your network connection. It can mean your keyboard, right? The monitor, things like that. So Linux is modeled on what's called the Unix kernel. And so Unix was a workstation / mainframe kernel operating system developed by Bell Labs in the 1970s. Right? So this is before anybody had a personal computer. Right? So these giant machines that used to take up entire rooms, this was the operating system that was being developed for them. So there's basically a different operating system for every computer manufacturer, right? Which is really awkward. That actually lasted for quite a long time. So that lasted into the 90s. Unix became one of the portable OSs, one of the first portable OSs, because it was actually written in C. Right? So it was written in a language that anybody, if they had a compiler, could compile the program and then run. Right? So people could actually get the Unix OS as source code, compile it, and run it on their computer. Right? But licenses for Unix were and still are enormously expensive. Right? So it's way too expensive for individual users. And that's why Linux was born. So 1983, this guy named Richard Stallman, some of you may have heard of him. He's a little bit, well, he's more than a little bit controversial. He's very controversial, however, he's also very influential in the open source software world. So he started something called the GNU project. And his goal was creating a free Unix-like operating system, right? Because no ordinary person could afford one. Right? And so him and the people that he was working with, they started working on this, right? You have to write a lot of code to produce a working operating system. They managed to do pretty much everything, right? They developed all the tools you needed to actually develop an operating system, except for the kernel. So they never wrote the kernel, right? So probably the most important part of the operating system, they never got around to writing, right? So the kernel is called herd in GNU, right? GNU is a herd animal. So the kernel was called herd. Development was extremely slow. There is a version of it now. You can actually download it and install it on your computer as part of your operating system if you like. But development is still relatively, what's the best word? It's not as active as the Linux kernel development. Okay, so that's 1983. About 10 years later, a Finnish graduate student named Linux Torvalds announced on Usenet, so Usenet's sort of like the Twitter of today, right? Except nowhere near as popular. He had an 803086 processor. I think most of you have probably not heard of this before. So your Intel processors, what are they called right now? Pentiums? They're called Pentiums, right? 386 is the many generations precursor of the Pentium, right? So like it's a long way away from your desktop processor of today. But he had one of these. The problem is he doesn't have an operating system for it because he can't afford Unix. So he decided, well, I've got one of these. I'm going to try to write an operating system. And so he started to write the kernel. And he borrowed the tools from GNU, right? And thus was born GNU Linux. Right, so this all started with a basic, well, the kernel started with basically one guy. The tools surrounding the kernel started with one guy and a few other people. And now it's grown today to be pretty much everywhere in certain areas of computing. Right, so today, Linux dominates the cloud infrastructure market and supercomputing. So anything, the backbone that drives the internet, basically, it's all Linux. Right, all the servers that are serving up your Netflix videos, Linux. Right? Android, most dominant operating system on smartphones worldwide. Right? North America, it's probably a little closer. It's probably not as dominant. But it runs on 70% of phones worldwide. Why? It's free. Right? So it's common on embedded devices. So small small devices where there's normally not a screen. And it's uncommon on the desktop. So a few of you I know put up your hand the other day to say that you were using it on the desktop. I occasionally use it on the desktop, but it's very uncommon. So it's roughly 1% to 2% of the desktop market, right? So very small. Unless you include Chrome OS and you count all of the laptops that kids in the US are using, because a lot of them are Chrome OS. Okay, so that's the brief history of Linux, right? In a nutshell, it all started because someone wanted a free operating system. Now Bash, what's Bash? Okay, so this is what a terminal is. Right? I should have flipped the pictures around. That, the one on the right, oh, sorry, let me set the pointer here. That thing on the right, that's how you used to interact with a computer. Right? There's a keyboard. You can sort of see there's a keyboard here. So you could type things into the keyboard, and your output didn't come to a computer screen. It got printed out on a printer. So that thing over there is the printer behind it. Right? And so that was one way that you used to interact with a computer. Right? That's called a terminal. Slightly more advanced is this thing here. Right? So now you can see the keyboard and you can see a computer screen. Right? Also terminal. Today, it's just a piece of software that represents your terminal now. Right? So the little text console that I'm showing you in the lectures, that's a terminal, but that's really just a piece of software. So it's not really a hardware terminal. It's a software terminal. Right? So that's actually called a terminal emulator. Right? And so this thing right here, right? That's your terminal emulator. Right? And every operating system, well, Windows, Mac, Linux, they all have their own terminals. Wrong course, hang on. Okay. Oh, wrong lecture. Okay. Okay, so that's a terminal, right? So that terminal is you can think of it as being the program that has the window that you can type into, right? Now, what's a shell? So Bash is what's called a shell. A shell is just another program, right? So it's a software program that interprets text that you type into a terminal, right? Well, yeah, so where does the text come from? It comes from a terminal. It interprets text, right? It doesn't have to come from the terminal. It can come from somewhere else, right? So there are many, many different shells. If you click on that link, you can take a look at all the shells that are listed there. There's dozens, right? Dozens of shells. Bash is the default shell on Linux. Do I tell you this somewhere? Here it is. Bash is the born-again shell. Okay. So it is, not surprisingly, an shell called the Bourne shell. Right? So Bourne, I forget his first name. Bourne was one of the people who's a part of the Unix development. He wrote a shell called the Bourne shell. Bash is an improvement to the Bourne shell, right? That works on Linux, and many other operating systems. So it's now the default login shell for most Linux distributions, right? So that is, if you grab a Linux distribution somewhere, install it on your computer, open up a terminal, that terminal is for the most part probably running Bash, right? Mac OS, it used to be the case that it was Bash until 2019, and they switched to something called the Z shell. Right, which is fairly compatible with Bash, but it's not perfectly compatible. This course is going to assume that you are using bash. Okay? So if you're on a Mac and you want to make sure that you're actually in a bash shell, open up a terminal and write exec bash. Press enter, and you will have a bash shell. Right? If you want to change your shell permanently to bash, which I don't recommend you do, you can look that up on the internet. There is a way to do it. It's just the change shell command. But you don't have to do it for this course. Just exec bash. There you go. OK. So terminal, right? Window, shell, thing running in the window that can interpret commands. Now we want to use our shell to actually do something in our computers. Right? Now a big part about working in Linux is you need to access the file system. Right? So you need to access information that's stored on your usually disk drive. Right? But it could be network or other things too. So for that, you need to learn about the file system. So a file system is the part of the operating system that controls how data is stored and retrieved. Right? And it's usually, when people talk about file systems, they're talking about something that's associated with physical media. Right? Hard drive, SSD drive, solid state drive, solid state drive, optical disk, something like that. Right? It can be other things. Right? It can be other things. There's many different file systems, right? Every operating system has their own. Windows has FAT, and NTFS. XFAT is the successor to FAT. Mac OS, not surprisingly, has the Apple file system. Right? Linux has a whole whack of them. You can pick whichever one you want. Right? So when you install Linux, you get to choose which file system you want to use. Most Linux installations are ext3 or 4. But there are many, many other options to choose from. OK, so file system. So on a file system, there's the notion of a device. Okay? So a device is the physical piece of hardware that you are storing files on. Right? So it can be a hard disk, flash drive, CD-ROM, whatever. Right? It's just the storage media. It's the physical storage media for your information. Right? So that's your device. Now, files. What are files? Right? So files, like what's a Word file, right? Or what's a PowerPoint file, or what is a Java file, right? When you get down to it, it's just ones and zeros, right? Everything's binary on the computer. Okay? So that's all it is. So the contents of a file are just bits, right? And as someone designing an operating system who's going to make a file system, you have to decide, well, how am I going to store these bits on a hard drive, right? So let's imagine, for the time being, right, that your operating system abstracts your hard disk as just a big array, right? And you all know how to use an array, right? An array or a list if you're a Python person, right? Right? So it's just this big list and it's empty, right? That's why it's gray. OK, now I've got a bunch of files, right? The contents of the files are just stored in the array somewhere, right? Here I've chosen the simplest possible storage, what's the word I'm looking for? Storage mechanism that I can think of, right? Every file is shown in its own color, and the blocks in the array are contiguous, right? So all the files for file 1 are in red. Sorry, all of the storage space in the array for file 1 is in red. All of the storage space for file 2 is in green, and so on and so on and so on. Right? This isn't actually how it works, but it's good enough for our purposes. Right? So file 3 is in blue, file 4 is in yellow, file 5 is in orange. Right? OK, now as the writer of the OS file system, right, what information do you need to store in order to know where the contents of any given file are? Anybody? It's not that hard, it's just an array. Yes?
The file name and the location, where it is?
Well, let's take the file name away for a second, but the location is right? You need to know, what's going on? Right? You need to know where in the array the file starts, right? What else do you need to know? It's not enough just to know where it starts. Yeah? You need to know where it ends, right? Or the size of the file, right? And there's a whole bunch of other information that you might find really useful as well, right? So for example, can anybody think of anything? Anybody? Yes? File name. Yeah, OK, we'll get to that in a second. That's a weird one in Linux. The name is weird. Yeah? The file type, yeah, that's good, right? So file type might be useful. Turns out, yeah, so the file type is useful. Now, the interesting thing about the operating systems is they all treat file types differently. So on Windows, there clearly appears to be a distinction of the file type, right? It's an exe or a pptx or a PDF. This operating system seems to know what they mean, right? That's not necessarily the case in other operating systems. What else? Anybody? Yeah.
File size?
File size, yeah, that's good. Anything else? Yeah.
Various forms of metadata, like when it was made, last edited, stuff.
That's exactly right, which is on the next slide, right? All you have to do is look at the next slide, right? So there's a whole bunch of information that you might want to know about files, right? Metadata being the important one, right? Data about data, right? So when was the file created, right? When was it last edited, right? When was it last accessed? Stuff like that, right? On Linux, information is stored about who owns the file, right? And other things too, right? So somewhere else, right? So it's not sufficient to have this array, right? Right? Does everybody understand that? Right? It's not sufficient just to have storage. You need some data structure that tells you where everything is stored, right? So a file system is more complicated than just storing the bits, right? You need information about the bits. And that's what an inode is in Linux, right? So an inode is a thing, it's a data structure, right? That stores information about the contents of a file, right? Such as blah, 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 right? One of the things, notice the last thing it tells you, right? Somehow it stores information about where the file contents are, right? If you're using a simple system like this, all you need is the array index of where a file starts, right? And if you have the size of the file, well, you're good to go, right? Because you know where it starts, you know how big it is, you know where the information is, right? It turns out it's a lot more complicated than that in real life, but this is good enough, okay? The details about how file contents are stored on a disk are way beyond this course, right? So that's what an inode is, okay? So it's a data structure, stores information about files. Every inode has an identifier called the inode number, right? So it's just an integer, right? It's a unique ID for an inode on any given device, right? So if your computer has one hard drive, so you have one device, then the inodes are all unique. Right? If you have a hard drive and then you plug in a USB stick, you now have two devices, right? So the two devices might have inodes with the same number, okay? So inodes are not unique across devices, right? So it's not a globally unique ID for the file system. Not terribly important for our purposes. Now, someone said file names. The inodes do not store the file names in Linux, right? So where are the file names stored, right? Okay, so what's a directory in Linux? Right? So a directory, most of you know, is the analogy of a directory in Linux, most of you would say is a folder on your operating system. Right? So in Windows, you're used to opening folders. Right? On Mac, you're probably used to opening what looks like folders. Right? Those are actually directories. Right? So in Linux, it's definitely a directory. But a directory is just another type of file. Right? So again, it's just a bunch of ones and zeros. Right? And at its very essence, it's just a table, two columns. Right? It's got a file name in one column, so that's where your file names are stored. They're stored in directories, right? And then there's an inode number, right, which is the identifier of the inode that describes the file, right? So that's all your directory is, right? Your directory can contain other directories, right? So dir1, dir2, and dir3, those are all directories, right? File1, file2, and file3.txt, those are all files, right? Notice they all have different inode numbers. Right? So dir1 has the inode number 45201, and so on, and so on, and so on. Okay? And so when you try to access dir1 somehow, right, your file system goes into inode 45201 to find out information about that directory. Right? When you try to access the contents of file1.txt, your file system runs off to inode number 43108 and accesses information about your file, right? And so on, and so on, and so on, right? The inodes are basically stored in just a big array, right? And the inode number you can think of as just being the index into the array of where to find the inode. Okay? Armed with that table, right, if you're reading the notes, page 5 or 6, there's a picture that's very hard to decipher, right? That's in the notes. But if you translate the picture into the table, everything becomes a lot clearer. Maybe I'll do that on Monday. For now, I'm just going to keep on going, okay? All right, so how are your directories organized on a Linux computer? Right, so that's something called the File System Hierarchy Standard. Right, click on the link, you can find out about the standard. Right, the standard defines the directory structure of a directory structure and directory contents for Linux distributions. Right, it's a standard, but not everybody follows the standard. Right, so you can easily find Linux distributions that don't have this directory structure. Mac OS is similar, right? So Mac OS is a Unix-like operating system. Its file structure is different, right? So if you're on your Mac and you're emulating commands that I'm typing into the console here, you're going to see different stuff, okay? But that's okay. It's similar enough, right? We don't actually care about studying the hierarchy structure in general, right? You can just look it up wherever you need to look it up. But there are some things that you should know about the way things are organized on a Linux file system. Okay? So the number one thing you should know, Linux file system has a topmost directory. Right? So there's a directory that contains all other directories on a Linux file system. Right? You cannot go above the topmost directory. Right? The directory is called / in Linux, or root. Right? People will talk about the root directory, or they'll talk about the / directory. Most people talk about the root directory, I think. Right? So it's named /. To change to the root directory from your shell, you just type cd space /. Right? And that changes to the, so if I type cd /, oh, hang on, let me change the font size on this so you can actually see it. I had to decrease it so I could run PacMan, which probably is not a good reason, but oh well. Okay. There we go. So I'm in the root directory. Sometimes, depending on which computer you're on and how your bash shell is configured, the current directory is shown right there. Right? So there you can see a /. So your shell is trying to tell you, hey, you're actually in the root directory. Right? How do I know? How do I know for sure? Well, there's a command called pwd. Right? pwd is print the current working directory. Right? So it says, well, you're in the root directory. Right? No, wrong one again. I'm going to close this. Hang on. Okay. So to print the current name of the current working directory, it's just pwd. Right? Print working directory name. Now, what's in that directory? So what is in the root directory on a Linux file system? Well, ls is the command that lists the contents of a directory. Right? So type ls into your shell and press enter and see what happens. Right? And voila. Right? You see that there's a bunch of stuff. Now, if you're on Mac, at least on my Mac, you don't get colors by default. So if you're on a Mac, you want ls minus big G. I don't know what it does on. Oh, it does the same thing. Okay. So if you're on a Mac, by default, ls is not configured to show colors. Right? You have to give it what's called the minus big G flag. Right? And then you'll get colors. You may get different colors than this, but you get colors. Right? The colors correspond to different types of files. Okay? Everything in blue is a directory. Yeah, everything in blue is a directory. Everything in that green, for our purposes, you can also think of as being a directory for now. Okay? So bin, even though it's not in blue, is in fact a we can think of as being a directory for now. Okay? It's a little different on the Windows subsystem for Linux. Oh, sorry. Okay. Now, there's a distinction between what are called built-in commands versus regular commands in a shell. Okay? So built-in commands are commands that are actually defined by the shell program itself. Right? So bash is a program. Right? The bash program itself understands a bunch of built-in commands. So there's a bunch of commands that are natively part of bash. right? Then there's everything else, right? So every other command that you type into the console, or into the terminal, or into your shell, right? That's actually just a program somewhere else that gets run by the shell, right? So commands are just executable programs. Some of them are built in, okay? So there's a distinction between the two, right? Now, the reason I'm telling you this is because if you want to get documentation for the ls command, for example, you can't, sorry, not ls, for things like pwd or cd, right? You can't actually get them in the usual way, right? So to get documentation for a built-in command, you have to type man built-ins. So man built-ins, right? And there you go. So there's your man page for the built-in commands that bash understands, right? On Monday, I'll show you how to navigate one of these things, right? For now, I'm just showing you how to access one of them. But it tells you, right, bash defines a whole bunch of built-in commands. And if you look at them, cd is one of them, right? Where's the other one? cd and pwd is another one, right there, right? So the change directory command and the print working directory command, those are built-in commands. ls is not on this list, right? Let, local, logout, popd, right? So ls is not in there. So ls is a different executable program living somewhere else on the file system, right? If you keep on going, you'll actually cd, right? So if you keep going, well, there's the documentation for cd, right? And if you keep going, well, I'm going to get to it a little faster. You'll get to the information for print working directory, right? So you can always look them up, but you have to remember they're built-ins, so you have to do man built-ins. All right. From current. Good? Okay. Now, everything else, if you're lucky, there's a man page for it. So then you can just type man space command name, right? So for ls, ls is not a built-in command. If you type man ls, you'll get the man page for ls, which is a very, very big man page, by the way. It has lots and lots and lots of options that you can feed to it. I'm not going to do it right now, okay? All right, good. Okay, the file system hierarchy standard, right? So back to how a Linux file system is organized. So in a picture, right, there's your root directory, right, the slash directory, right? Underneath that directory, there's a bunch of other directories, right? We just saw them a second ago, right? One of them is called bin, okay? So bin is where the essential command binaries live, right? So for example, commands like ls, the program that corresponds to it lives in your bin folder or bin directory, right? Home is where the user home directories are. So on a Linux system, in the home directory, on my computer, there's a directory called Burton, and that's my home directory, right? If multiple people use this computer and had an account on my Linux system, they would have their own folder in the home directory, right? So when you go into CASLab, you're going to actually, CASLab's organized differently. I shouldn't have brought that up. Okay, never mind. Root. Root is the home directory for what's called the super user of your system. So the super user is the administrator, the person with godlike powers on your operating system, right? The super user can do anything on your operating system. Ordinary users are restricted in what they can do. So for example, the super user can go into the root directory and delete everything in the root directory, right? Thus nuking your entire operating system, right? Ordinary user can't do that, so you don't have to worry about breaking things. Okay, just go into your root folder and try deleting it. It won't work unless you force it to. Okay, user USR. So that's another place where read-only application data lives. Basically, if there's a program installed on your computer, there's a good chance it's somewhere in the user folder. Right? It could be somewhere else, but there's a good chance that the first place to look is somewhere under user. Okay, now, to list the contents of a directory, right? So now I'm basically just going to be using these commands. I'm just going to be using ls, pwd, and a few other commands now. If I want to list the contents of a directory, right? So I want to know what's in a particular directory, you can use ls space and then the name of the directory to find out what's in there. So I want to know what's in the bin directory, right? I know the bin directory is under the root directory, right? So I can write ls space / bin, and that will tell me what's in the bin directory, right? So again, print pwd, right? I'm in root, right? Everybody can see I'm in root. ls root bin will print out all of the files in the bin directory. You can see there's a lot of them, right? And this is why nobody can remember what all the Linux commands do, is because there's so many of them, right? There's a bazillion of them. Okay, so, but if you look carefully, if I can find it, I'm not going to be able to find it, am I? ls is in here somewhere. Right there. There it is. So ls is just a program that lives somewhere in your file system. Yes? What do all the colors on that mean?
Some of them are highlighted and then some of them are not.
Yeah. So the colors are complicated because there's lots of things that the colors encode. So ls minus al pipe to less. Okay, so now I'm not getting colors, right? But you're getting a lot more information about what things are. Okay? Some of these things, there's a D in the first column right there. Okay? Some of these things are directories. Directories are shown in a particular color, depending on how your coloring scheme is set up. It's not the same everywhere, okay? There's this thing L, right? That's called a link. It's going to have a different color, right? You're going to have executable files in here somewhere. Oops, sorry. Oh, wait, I'm in the wrong directory. I wanted to do ls minus al bin, pipe to less. Oops, sorry. Sorry. Come on. /*. There we go. Okay. A lot of these things, you're going to see an X in them. That means they're executable files, right? Which means they're runnable. So they're commands. Those will be highlighted in a different color, and so on and so on and so forth, right? I bet you thought the answer would be simple. It's not, right? It's a little more complicated than just what do these mean. Okay, go away. Thank you. All right. Any other questions? Just shout them out.
How come I can scroll like here in the service thing, but I can't scroll in the main?
Because the man page is actually running a different program to show you the contents, right? But if you type, what is it, H or something? It says type some letter for help, and then you'll see how to navigate it. But I'm going to show you how to do a little bit of that on Monday. Okay, so why did I type /bin, right? Okay, so so there's a thing called an absolute path name, right? So a path name is the name of a file that uniquely identifies the location of a file, right? So it's right. So if I give you a path name, you can actually find the file that corresponds to that path name. An absolute path name includes all of the directories that you need to get to the file, starting at the root directory. Right? So you start at the root directory, you list all the directories that take you to the file, and then you list the file name. In Linux, directories are separated with the /. In Windows, it's the /, which causes all sorts of problems. Right? Okay, so / that is an absolute path name of the root directory. /bin, absolute path name of the bin directory. /bin /ls, absolute path name of the ls command, right? /home Burton /CISC220 test exam PDF is the absolute path name of the exam file, which it does not actually live on this computer, right? I just made it up. Okay, so that's an absolute path, right? Start at the root directory, list all of the directories that take you to the file, separate the directories with a /. Most people don't use absolute paths, right? Most people use what are called relative paths. Right? So a relative path name includes all of the directory names that lead to the file, but you're starting from the current working directory. Right? So, for example, suppose I'm already in the directory home Burton CISC220, CISC220, right? I'm in that directory. Okay? Then the path name tests, that's the relative path name of the tests folder. Right? Test /exam is the relative path name of the exam folder. /test /exam /exam PDF, relative path to the PDF of the exam, and so on and so on. Right? It doesn't start at the root, it starts at the current directory. right? So that means instead, if I'm in the root directory, I don't have to type ls/bin to list the contents of the bin directory, right? I'm already in the root directory, so I can just type ls/bin, right? Or ls/etc, or ls/etc calendar, or ls/user local bin, right? So that will list the contents of the bin directory. The second one will list the contents of the etc directory. The third one will list the contents of the etc/calendar directory, and so on, and so on, and so on. Okay? Now, any command that requires a path name will accept a relative path name, right? So, for example, starting at the root directory, right, I can type cd etc, print working directory, cd calendar, print working ls, right? So I can use relative path names. So let's do that. Right? So instead of typing, which one? Hang on. etc calendar is what I want. Okay. So print working directory. I'm in the root directory. Right? What's in etc? Well, I can do ls etc. A whole bunch of stuff. Right? What's actually in there is not important for our purposes. Right? ls etc calendar. Right? And there's one file in that directory called default. Okay? Or, if you want, right? Oh, sorry. Okay, so, right, so again, we're in the root directory, right? What's in the etc directory? All that stuff, right? Now, what happens if I switch to the etc directory? Right? So what if I do cd etc, right? And I do pwd? Well, I'm now in the root/etc folder or directory, right? If I do ls there, well, there's all the stuff that I got from before, right? Now, what if I switch to the calendar directory, right? Print working directory, I'm in the root etc/calendar directory. What's there? Just this file called default. Okay? So relative path names, absolute path names. Most people use relative path names, right? Occasionally, you will need an absolute path name, but for the most part, you're going to be using relative path names. Now, when you do that, though, you have to remember what ends up being the result depends on where you are right now, right? What directory are you currently in, right? Because a relative path name is from the current directory. Okay. cd. So cd is the command that you use to change to other directories, right? cd on its own takes you back to your home directory, right? So in Linux, there's a notion of a home directory for a user, right? Notice it prints out something weird here, right? That thing there. It prints out the tilde, right? So we'll get to that in a second. But the absolute path of my home directory is /home/Burton, right? And that's what it would be on most Linux systems, right? So if Fred had an account on this computer, it would be /home/Fred, right? And so on and so on. Okay, so what's tilde? Well, tilde is the short form for the current user's home directory, right? So, but you have to be careful about that, right? That's normally what it is. But the user of the computer can change where tilde points to, right? So they can change tilde to point to somewhere else if they want to, right? But normally, it's your home directory. So you could type in cd space tilde, and that will take you to your home directory. Dot is the short form of the name of the current directory. Okay? So dot is the current directory. Dot is the name of the parent to this directory. Right? So it's the directory it's the directory immediately above the current directory. Right? So we can do all this. cd tilde, that'll take you to your home directory. Right? cd dot. Well, dot is the current directory, so that does nothing, right? It leaves you where you are. cd dot dot, takes you up one directory. So that'll take you into root home, right? CD again takes you back to the home directory. So on this computer, it'll put me into home Burton. CD dot dot slash dot dot means go up, right? So that takes you up 2 directories. So let's take a look at all that quickly, right? So print, I'm in my home directory, right? CD tilde. Well, I'm still in my home directory, right? Because tilde is just the short name for my home directory. CD dot means change to the current directory, right? So that doesn't do anything, right? CD dot dot goes up. So that takes me into root home, right? I'm going to go back to my home directory and type in cd dot dot slash dot dot, right? That will go up 2 directories, right? And now I'm in the root directory, right? You can do all sorts of weird things, right? You can do cd up dot slash up, right? Don't do that. It works, but don't do it, right? That takes you up 2 directories, right? Go up 2 directories. Sorry, go up 1 directory, go to the current directory, go up another directory, right? So you can do that if you want. Don't do it, okay? Boom, boom. What else do we got here? Oh, that's the end. Hey, that's perfect. Right on time. Okay, so that's a quick lecture, pretty quick lecture, on how to navigate your file system, right? On Monday, or whenever the next lecture is, we're going to be doing, what are we doing? Oh, you're going to be learning how to do things like create files and remove them. Let me leave that up.